Hello and welcome to Inside Modular, the podcast of commercial modular construction, brought to you by the Modular Building Institute. Welcome everyone, my name is John McMullen. I'm the Marketing Director here at MBI. Today I'm joined by Trevor Schick, CEO of AIIR Intelligent HVAC. Trevor is here to talk about energy efficiency and resiliency in modular systems and how modular builders can optimize their HVAC strategy. Trevor, welcome.
Welcome, John. Thanks for having me. Looking forward to the discussion.
No, I appreciate you being here. Tell me about yourself, Trevor. What's your background and what led you to focus on HVAC and energy strategy in the built environment?
Like most, it's a long road that got me here. I look back to my history. My first 20 years in business was all in high tech. So I was at companies like Apple Computer, Motorola, Hewlett Packard, spending a lot of time on global supply chain in those industries. And similar to what we're seeing in HVAC, in those days, the hardware is really coming commoditized, right? You think of an Apple versus a Dell. Most of the components inside those systems are the same. Most of the companies that build those systems for them are the same. What started to differentiate them was really kind of the customer experience that you gave them and the software that you could put in those to make that better customer experience. And then as I started to pivot and somebody pulled me into the real estate and construction world, it became evident to me that kind of that trend we saw in the electronics industry was what we really needed to move into in the HVAC industry and be able to give a better product with the same type of hardware put together better, but then really build that software layer on top of it that can bring, a better cost, better environment for the developer and the builder, but also give a better end user experience to the person that's using the space. And that's what got me excited about it. And been in construction for 10 years now, and I'm still excited every day to come and push some of the products that we're building.
Considering your background and from where you're sitting today as CEO of AIR, how has the conversation around HVAC and building performance changed over the past decade or so?
Yeah, I think, if you look at the past, right, people would design the building, then they'd kind of think about the HVAC and they'd look at different systems put in there. And I don't want to say it was an afterthought, but it was much further down in the build and design cycle for the buildings. What we're seeing today is it's really had to become a core driver of the way that that building design is done. And that's because we can really save a lot of money for that developer based on, that upfront design. Simple things like if I don't need a VTAC in the corner that takes a 3x3 closet, I'm suddenly saving that developer not only the 9 square feet in the corner, but I'm selling them the space that now they can push and use all of that, call it 24 feet of space because the whole width of the room and get a lot more usable and rentable space in the unit. And so, historically, people in our area looked at PTACs and VTACs and VRF systems, but what we really wanted to do was introduce this intelligence layer with a better product that can then bring value to those developers and the people that are building these spaces.
So one question I wanted to ask you, and it seems very topical at the moment. Energy volatility is a big topic now, especially for building owners, that, like you mentioned. How is uncertainty around energy prices influencing HVAC design and investment decisions from developers today?
Yeah, I think, in the past, most of this was looked at as kind of what do I do with the first cost, right? How much is it going to cost me to build in this specific type of HVAC system into the product? And most of those systems were either fixed systems where, they had one set point that was managed, or some of them had some variable to them, but no real intelligence built into the system. And what that did was it led to not getting the energy efficiencies on the back end. So you might get a better first cost savings, but over the 30-year cycle of that product, you weren't getting the operating efficiencies that you want to get. And to be fair, what most people had end up doing was over speccing the system because they needed to make sure that they could hit, that one high set point that was kind of at the max. The way we think about it is much different, right? I need to be very competitive on that upfront cost, give them a simpler system from an install perspective that can help drive down their upfront costs, but then give them the 30 to 40% efficiencies on the back end, which then allows them to not only get the first cost savings, but when they're doing the pro forma for the building, they're actually able to then build in, especially if they're the operator, those long-term cost savings from the energy efficiencies. And this is how we start thinking about adaptive systems. It's interesting because I think about it as, and you'll hear this term more and more these days, is physical AI, right? Everyone knows AI, right? You use your chat GPT, you use your Anthropic. It's really just a software tool that, you ask it a question, it generates an answer and gives you some predictions of what your answer might want to be. Physical AI is a little bit different. It's the idea of you use sensors to kind of understand the environment that you're building in, right? So once you get that product in there, it understands what's happening inside with occupancy, temperature, humidity. It understands what's happening outside with humidity. Where's the light coming from? Is it a sunny day or a cloudy day? And it senses all these things. It then optimizes them to the system by using variable speed compressors and fans. And then at the end of the day, it learns from it. So did it do the best thing to give a good user experience, but at the same time, be able to save money on the efficiency side or save benefits on the efficiency side? And then it learns and then it continues to build. And that's what AIR has really done is we've said, let's simplify the system down, but give them that same or better experience that a complex full building system would give them. And that's where physical AI has now moved from other spaces and into this HVAC space, which is what we're pretty excited about, and then brings those energy efficiencies to the owner operator.
Well, that's fascinating. I'll be honest, I hadn't really considered such a thing as physical AI, but it makes complete sense when you describe it that way. Climate policy now is pushing many regions towards electrification. What practical challenges are building owners running into as they move away from traditional systems and more toward these intelligent systems that you've described?
Yeah. Well, I mean, at the end of the day, as electrification happens, the grid constraints become a real problem, right? They become a problem for, no matter what industry you're in, but the builder. And if you think about it, in the residential space, and I'll use that term a little loosely, think student, single family, multifamily, hospitality, right? Kind of that whole space, 30 to 50+% of your energy is being used for your heating and cooling. Think of what a 30% savings to 50% of your bill adds up to, right? This becomes a much larger benefit when you think about how much that energy cooling and heating is going to do for you. And the only thing that I know about what's going to happen with regulatory climates, all the other things you listed is it's not static, right? It's going to be different next year. It's going to be different 5 years. And it's going to be different in 10 years. And so you really need to design for the resiliency. And that's what our software sitting on our systems allows us to do. Number one is it understands what's happening in that environment. So if climate change is happening in an area and it's suddenly getting warmer there, my system's figuring out how to maximize that benefit, right? Being able to bring back the most cost savings as possible. If people are, humidity is changing because there's more storms coming in, I'm able to manage that better than anybody else because I'm not a static set point system. I'm really taking this from the perspective of understanding my full environment, learning, and as that changes, my system continues to learn and does it. So in a world where those things are going to change, price of electricity is going to be changing up and down. The exterior environment is going to be different. You need to make sure that you're building a system that can be resilient to that. So in 5 years, you're not having to replace it with a different type system.
You talked about resiliency, which is a huge topic, I know, and considering related topics like peak demand and grid outages and energy flexibility and all these topics that are in the industry right now. I was wondering if you could share an example of a project where energy volatility or grid limitations directly influenced HVAC strategy.
Yeah, so I would say, I'll take it back a little bit to the resiliency of more of the operator side of things, right? At the end of the day, they're very focused on needing to make sure they have uptime, right? What's my resiliency built into the HVAC system that allows me, let's say as a hotel operator, to never have a room down? Because every night that room isn't being used, it's costing me money, right? It's a fixed cost that I'm going to be paying for that room to not be used. So resiliency to us is, if you think about some of these large, more complex systems, you have one system that might manage 20 rooms. If that system goes down, you have 20 rooms go down in that building, right? Normally, you got to get somebody out there. There's a lot of piping that's happening exterior to this system. Somebody's needing to come in and manage all those pieces. For us, because we have a simpler system and it's an in-unit system, if that room goes, if that system goes down, one, it's only one room that it happens to. Number two, because it's a through-wall system, I'm fully packaged. I literally can send somebody in there and within an hour, I can have that system replaced, that room back online, never interrupted my customer experience because, well, maybe for an hour I have to send them downstairs to grab a bagel, but beyond that, that room is going to be up and running. And number two, I am then not bringing down and losing the money by having an empty room in there. So resiliency for us looks very heavily at how do I make sure that system never comes down? Now, to take that to the electrification side of things, a lot of these operators and the grid owners are starting to look at who's using the most energy on that system, right? And if you're using the most energy on the system, they're looking at ways to then manage that for you almost. What we're being able to bring to the table is, we have an 18 SEER rating right now. So we're very efficient from that perspective. So when somebody's looking at the buildings that we're in, they're going to see a much better level of efficiencies across that building.
So when you're looking at a building's life cycle, be it a hotel or any other sort of building, 20 to 30 years out, how should owners be thinking differently about HVAC planning in this energy environment we find ourselves in today?
And again, I think it goes back to is owners need to make sure that, they're not designing just for today, right? They need to be looking at systems that can be out in the future, right? If you look at, use something very simple like the refrigerant that's being used today, right? I've been in this business probably less than most people that watch this podcast, but I've been in it about 10 years, right? I think there's been 3 to 4 different refrigerant changes in that time frame, right? And they're all driving towards one, how do we become more environmentally, effective? A lot of those old refrigerants were bad for the environment. But number 2 is, how do we then optimize using those refrigerants to get better efficiencies, right? I can guarantee down the road that's going to switch again. But what we see happen with those is that those new refrigerants get introduced are usually more costly than the old ones, right? It's your classic supply demand, right? When there's low volume of it, your costs are higher until you get up to high volume and then it gets lower. What's great about systems that are kind of compact, full systems like ours is I use so little of that refrigerant that it avoids a lot of the problems these guys might have down the road, right? I don't need detectors for my refrigerant because the new A2L is slightly flammable. Don't want to overstate it, but you do need sensors at a certain, if you use a certain amount of ounce of the refrigerant, so we don't need those. And then we're able to bring that packaged system that if I replace it, I don't need to go figure out, do I need different piping in there for this new refrigerant? Is there a different setup? Because I'm a fully packaged system. So when they say 10 years down the road, and maybe my system lasts 15 because we're running it more efficiently. But at some point you're gonna have to replace the system. They just pop theirs out and put mine in. They're not having to go up to the roof, put in a different compressor, run different piping. There's a lot of things that we're building into it that allows them to kind of have that upgradability without the cost that a lot of them are going to have to pay for that upgradability.
What are some of the biggest mistakes or misconceptions you see developers making when planning HVAC systems today?
I think for me, it's twofold, right? One is a certain set of them just really focus only on first time costs, right? And I get why, right? If you're building a multi-family apartment, you're building that unit, it costs you a certain amount of CapEx to go build it. And by the way, your operating expense is being handled by the guy that's renting the unit. And so it's a little bit difficult in some spaces for them to look at this and say, hey, why the operating expense? I can't write that into my pro forma because I'm not getting those savings somebody else is. So from our perspective is you have to have a system that's competitive day one on the CapEx side of things. And when I say that, it's not only from a cost perspective, but again, I will go back to the new systems that are coming out with this physical AI built into them, give a much better user experience, right? I don't talk about what temperature I'm running at. I'm saying what's my feels like temperature in that building, because really the end user customer is all about humidity. It's all about what that set point temperature is. It's all about whether the wind is blowing on me, right? We've all been in the hotel room where a PTAC's blowing cold air at you, right? And that's a bad user experience. The other piece of it that comes to play is, making sure that we have enough fresh air coming in, right? Air quality has become such a big thing in a lot of these buildings. And so, making sure that they think about, yes, I need a good CapEx up front. The cost has to be first cost competitive. But even those spaces where they're not getting the cost savings benefits, the end user is, making sure they understand that, that feels like and that customer experience can bring them a lot of benefits from both a customer satisfaction perspective, but also when they sell the building, the value they're going to get for the building. So I think that's one thing. And sorry, that got a little bit long. The second one is the design side of things, right? When we can work with developers and help them out on the design side, and this really applies to the modular guys as well, which I'm sure will get, tie us a little bit tighter up as we go forward here. But, being able to get designed into those systems, as I said, in a hotel room, and we've worked with the big brands, if I can take that PTAC out, that PTAC sticks 2 feet into the room and I cannot put a piece of furniture up against it. If I can make that flat against the wall, my blower's up at the top, just like a VTAC. Now I can push furniture right up against it. Now I have the option of, do I rent it with more usable space, which probably works very good in a multifamily because they care about square footage more, or in hospitality, can I take 18 to 24 feet out of the size of that building? And if you think of construction costs of $250, $275 per square foot, which is, plus or minus, as some people say it's 200, some will say it's 300, but the math works regardless, right? Suddenly I take 18 feet with $250 per square foot out of that building cost. That is massive from a first-time cost saving. So it's not just the cost of my unit, it's what are those other incremental pieces that I can bring to that developer that allows him to save money. Even on things like I can now give him his roof back, right? He doesn't need compressors up there. Put in your dog park, put in an outdoor barbecue area. Those are all things going to raise your amount of value you can bring to the customers, but it still give them a better experience because the system I'm bringing in can beat them on sound. It can beat them on customer satisfaction from an occupancy perspective. So that's the way we think of it. You can't just take it as a singular, what's my CapEx? You got to look at how it fits into the whole picture.
Well, you mentioned modular, and I did want to pivot a little bit more to that audience. From your perspective, how does designing for factory-built construction change the approach compared to traditional stick-built projects?
Yeah, and it's fun. I've lived both worlds, right? I kind of was on the stick-built side of things, and then I think I mentioned earlier, I might not have. I was with Amherst Holdings, which is a single-family rental group out of here in Texas. And one of the things that I was at the beginning of with them is starting their studio built projects, which was, they normally were I'll buy a home, I'll renovate it, then I'll lease it. And then we kicked over to a project where we started modular building with some of the big players out there, all the way through to now having their own factory. And so I was able to start thinking about how does this HVAC system get brought in even before I became the CEO of AIIR Products. So, I kind of live this world. And what's really important to it is being able to do everything in the factory, right? The biggest savings you can bring in modular is being able to take a product, the modular product, bring it to the site and have to do as little amount of work on that site as possible. And it's really for a couple of reasons. One is cost. Factory labor is a lot less expensive and more efficient than field labor, number one. But number two is in the field, you need to kind of get all the trades working together. And that's difficult to do, right? You need to have your electrical guy there at the right time. You have to have your plumbing guy there at the right time, concrete to put your pads in. All those things need to come together, and that orientation usually takes schedule. And part of the problem with a lot of the modular is they've always said we can build it much faster, and the answer is yes. But if the subcontractors in the field aren't available to do that, you still end up with these long schedules. What we look at with these package systems is you don't need any of that, right? When our HVAC is put into a modular unit, or when any package system is put in there, it's done, right? Literally, they drop it down on that site. They run power to it. They'll probably have a drainage for condensation. But besides hooking those two things up on the site, which you have to do regardless, everything else is in that package system, and you don't need to do it. So all of that work is done, number one, in design. So it goes back to the conversation earlier about getting that integration of design up front. But then number two is making sure that everything you can possibly do in the factory, which for our system is all of it, can be done and then delivered to the site and not have to be touched on the site. I've now taken out the mechanical trade for the HVAC. I'm not having to run ducting. I'm not having to run piping. All those things go away, right? That just saves money for them on the back end. And just as importantly, in many cases, it saves them schedule, which means they can get that building up and running faster.
So you mentioned the benefit of package systems going into factory built projects. Many modular projects serve sectors like healthcare, education, workforce housing. Do HVAC considerations differ across those different building types?
I think they do. Again, my world's pretty focused on residential, right? Kind of the categories I talked about earlier. But obviously, just as a person in the industry, I mean, they do. There's different things that are critical to those folks. Healthcare, it's all about reliability, right? I mean, there is nothing more critical in the healthcare side except education. It's a lot of scalability, right? Schools usually come up fast, and then they need to be able to scale them as time goes on and be able to make sure they can get it there. Housing is very focused on cost and comfort, right? So I think they all now. If I went back to healthcare, do they care about cost and comfort? Of course they do. But it's kind of how you stack those priorities is different, but the priorities are probably about the same. The thing that's across all of them, the goal is the same. You got to deliver consistent performance with minimal complexity while improving the customer, the occupant's experience, right? So they all have the same end goal, although you might stack rank those a little bit different within them. And so that's why you got to get systems that, are built differently today than they have been in the past. Now, what I would say is if I look at healthcare and I look at, again, some of the bigger buildings, right, factories and those type of things, there's been a lot of work done on building in AI into those projects, moving much more to variable speed because that cost and the electrification is so high for them. I think in the residential space is where it got left a little bit behind, right? You have a group of players out there that are very large, very established, high market concentration in their spaces, and they get into a little bit of the innovator's dilemma, which is, do I go invest millions of dollars to build a product where I probably won't gain any more market share? And it happens. And that's where startups like AIR come into play because we're able to say, I'm going to take a blank piece of paper, which is exactly what we did. Physically, I'm going to design a better system, right? And I can do it cost effectively because I'm just able to really start with, the blank sheet. And then you bring in guys like me and some of the people I've brought in that come from other industries, you in the phone industry, right? I work for Motorola in the cell phone business, Apple in the cell phone business, right? The goal there is bring on a product with 2 to 3x the amount of technology built into it at a lower cost with every product introduction you do. That isn't something that kind of starts in the construction industry, right? You can look at it over the past 50 years and you can go get your data from McKinsey and everybody else. But the building efficiency has actually decreased over time, right? From how quickly can you build it? How good is the building? And that's, part of that's regulatory. I don't want to minimize that, but we're trying to bring some of that, knowledge of using software and hardware, being able to start from scratch and build out those products to really go after this market for the residential side and really get that caught up to some of the things we're already seeing in some of those other markets that you highlighted.
So, how important is early collaboration between HVAC engineers such as AIR, modular manufacturers, and developers when you're designing these HVAC systems?
Yeah, I mean, your true benefit comes with that early adopter. I talked about the space savings, right? Because again, that you only get that if you do the design piece up front. And so, I call that kind of the key to it. But even things like, as you think about do you have to put a compressor on the roof, right? Do you need to put it outside on a pad? How much, are you putting ducting in, right? I mean, simplistically, when you use these big complex systems, you're ducting them through the buildings. Well, suddenly my ceiling height's lower. Well, not only does that cost you more money because you're having to put, the ducting in, but you're also giving a worse user experience, right? Anyone who walks into an 8 foot high ceiling versus a 9 foot high ceiling just feels a better space to go after. And so, being able to work with them up front to give them back those safe space savings, bring them the true cost efficiencies in that design side of things is absolutely what makes it so effective for those modular builders. What's great about them and why a product like ours works so well in their model is I am so easily repetitive. Every single unit of mine, we're a through wall system. We fit between the studs that they already have in that building. They just pop in a sleeve and then they put in the system. I mean, literally, if I do it on site, it's probably a 2 hour install, maybe an hour and a half. If I do it in the factory, it's probably 15 minutes. Think about the amount of work it takes when you're in the field to bring in all those different trades, coordinate them together, and get that HVAC system put in. So, that's the way we think about it. One, on the design side, I can bring you the cost efficiencies of optimizing the space better. But then number two is just purely that factory built mentality that the modular guys are so good at. That's why I love them because it's my background. They're able to understand the value it brings to be able to have a very repeatable system that can go in. And then, by the way, if there's an issue in the field, as I said earlier, pop one out, put the new one in, you're back online within an hour.
Earlier in this conversation, we were talking about a lot of the new technologies that have come into HVAC, how they're built in with intelligence layers now. So I wanted to go back to that for a minute.
Yep.
As buildings electrify, do you see technologies like those we talked about earlier, like thermal storage, smart controls, demand response? Do you see those playing a bigger role?
Yeah, they have to. I mean, it's if you think about thermal storage is a little bit of a different animal, right? It's being able to make sure you have conditioned space is critically important, right? Because at the end of the day, we look at it from the perspective of how do I make sure I'm bringing in fresh air, but I'm conditioning that air before it goes in, right? So that I'm not, when I'm sending new air, fresh air in, I'm not sending cold air into a warm room and then having to turn back on the system, which obviously decreases your efficiencies. When you get into the sensors and the controls, that's where all the secret sauce is, right? Number one, be able to have the right sensors, and the stuff out there today is unbelievable what it can pick up, right? My sensor knows whether that's a cat walking across the room, whether that's a dog or that's a person, right? How many people are in that room? What does that number of people in that room drive from a heating perspective in that room? Because what the system's all about, what our AI does and the machine learning I talked about, is it understands that and starts predicting better what's going to happen. Because the best thing I can do is run my fans at a level 2, a level 3, right? We have 9 levels in our system of different speeds with the compressor and the fan. And the most efficient way to run that is run it at a low, a low level, but that's a better user experience too, right? Because they're not hearing this big system kick on. They're not getting the wind blowing across the room. They're getting this great experience inside of the room, but then I'm able to condition all the air that's coming in. So they're getting the fresh air piece without having to kind of cycle the system up and down. What's become interesting to us about it as well is you kind of think about the long-term effect of that is from a warranty and usage perspective, right? It's like a car, right? If every time you're in your car, you just go up to 100 miles per hour, then you slow down to 20, then go up to 100 miles per hour, that car gets way too much wear on it and doesn't last as long. Our systems kind of run at this constant speed. We'll kick it to high if, for some reason the homeowner wasn't home or, hasn't predicted what's going to happen next happens. But most of the time, especially after a few months, as our machine learning has gotten better and better, we're able to predict exactly what's going to happen, right? And that allows us to get, again, it's a better user experience. Back to your point on those controls, why they're so important. It drives those controls and gets the learnings for us. And then every day our system learns and gets better. So we're going to do a better job today than tomorrow. The other piece that becomes interesting with it is that when you think about these big systems, they're trying to condition 5 rooms, 10 rooms, 20 rooms, right? If that room's on an outside wall to the south, it's much different than an outside wall to the north, right? The day the sun's up, when it comes up, what's the weather like at that point? Our system continues to pull that data and understand it and get more efficient, very specific to every single space that we condition versus trying to do that at kind of a building level. We do it at a space level, one system at a time. It is your true edge computing. Every one of our systems has a microprocessor on it that can figure out what's going to happen, take the feeds from those sensors, use our AI to get smarter, and then give that optimal customer experience at the best efficiency somebody can have.
Well, that is fascinating. To be honest with you, what do you think the biggest opportunities are for modular manufacturers, considering all these new technologies, the sensors, the machine learning? What are the biggest opportunities for them to innovate when it comes to HVAC integration?
I think a lot of it's on the design side, right? So being able to innovate better designs by being able to use these newer technologies coming into play gives them a huge upsell, right? Again, you think about the modular space going into hospitality, right? Those guys can now come in and say, a Hilton product, let's say, hey, yes, you said you need your room to be, 24 feet long. You can make that 22 feet long because of the benefits of this new system going in there and give a better user experience. The other piece that we find a lot of in hospitality, it's so critical, but I'd say multifamily student are right behind it is noise, right? I mean, you think about those modular guys, they're able in the factory to build a very, tight system, which, every time you have a crack or there's something in that system, it allows more sound into it. We're able to give the sound performance of a complex kind of building level system, but do it in a package system that, anybody who's stayed in the hotels like I stay in, right? Those PTACs and VTACs, when they turn on, they're waking me up, right? And it's just, it's loud, it kicks on, you get the wind blowing across the room. And I tell people all the time, it's a classic, you're cold, but you have sweat on your arm, right? It's because the humidity is not right. The modular guys can go into these developers, say, one, I can save you money on the physical size of the rooms and the way you want to set that up. But number two is being able to give that feels like temp and using our AI then to give them the better efficiencies. I mean, I hate to say it's a simple solution. It's all about simpler hardware with smarter controls versus these complex systems. And I'd say the biggest thing, and I think the modular guys are a little better at it than I'll call it the standard guys, it's a new technology, right? And so historically, this industry has been built on oversizing systems to these rooms. Like we'll go into rooms and they'll be like, we're putting a 2-ton system in here. And I'll say, you need a 3/4-ton system and you'll have plenty to get this room right, as long as you have the smarter controls and the software that we're putting on top of it. They normally look at us like we have 2 heads. We get beyond that. We simulate it, we model it, we show them that it's true, and they're like, that's great. So now they've saved money on their upfront costs, and then they're getting that 30-40% efficiency savings in the back end. It's just a change in mindset that we got to get them to. The modular guys are much better at this because they're manufacturing guys and they understand it. But it is going to be the wave in this area, and I'm just proud of my team for being able to bring to market the first product to really take advantage of it.
Well, Trevor, I said earlier, this has been fascinating. I've learned an incredible amount about HVAC in just this conversation. I really appreciate your time today. I can't wait to see Air Products in the World of Modular exhibit hall in just a
You
few
bet.
weeks. Thank you again for your time. I really appreciate it.
You got it. Thanks, Don. Talk to you soon.
My name is John McMullen. This has been another episode of Inside Modular, the podcast of commercial modular construction. Until next time.